Welcome to week 14, where we are going to talk about the first derivative test and the mean value theorem. My name is Bethany Curia, and I am with Biola Youth Academics. A reminder that you have two IMAX sections this week, not one but two. Please make sure to complete both of these and submit the work for each section individually to receive credit. Both are due on Sunday. Because of the two IMAX sections this week, I chose to have an open discussion, and it will not be graded. I've noticed a lot of students really haven't been taking advantage of this opportunity to ask questions and post topics that they're really struggling with. The topics do not have to be just from this week. They can be previous topics that you're still having trouble with. Please go ahead and post those questions, post those topics, so that while I'm building your conference this Thursday, I can make sure to pick questions that relate to what you want to practice. This is our last conference until January. Please make sure this is a priority. I know it's a busy time of year. I'm asking for 1 hour this week to sit down and work through some problems and kind of guide you in the right direction for review over the next few weeks. Your textbook homework is due on Saturday. There are two sections this week, 4.2 and 4.3, and I tried to make it an equal balance between the two sections. So let's go ahead and take a moment to take a look. Oh, before we do, we have an exam tip for you guys, and this one's really important with several weeks off in your future. By this point, you should be starting to review for the AP exam on your own time, not prompted by the course, not prompted by me, but on your own. You should be starting to review on a regular basis. You should be going back and looking through especially the sections where you really struggled with the homework, or maybe some of the exams where you didn't quite get the score that you wanted to. You should be going back, reviewing the material, and trying those practice problems again. I would very strongly recommend that your break not be completely math-free, and that you are focusing on some of these areas that you need to improve before the AP exam comes in May. Trust me, this test is coming much faster than you think. So this week's topics are the mean value theorem and the first derivative test. All of the videos for the mean value theorem should have been watched last week. They were included in the week 13 videos as a precursor to this week, so you didn't have too many videos to watch this week. If you do need to reference them again, the videos are there for you. So go ahead and check back to week 13 module if you'd like to see the mean value theorem videos again. And then you will find first derivative test videos from Khan Academy, as well as this video in your week 14 module. You'll notice that some of the content for the first derivative test will seem familiar because the task of identifying local extrema came from section 4.1. In these first two steps that we talk about in the first derivative test, taking the first derivative and setting it equal to 0, that's exactly how we found our local maximums and minimum values. What's new this week is this bottom step, where we're going to find where our derivative values are positive and negative. The positive values mean the original function f of x is increasing, and the negative derivative values mean that f of x is decreasing. Now remember, a derivative is an instantaneous rate of change, or a slope of a curve. So we are trying to look for where the slope is positive and when the slope is negative. If our slope of a line is positive, our line was increasing, and if the slope of the line was negative, the slope was decreasing. In dealing with our functions with curves, it's the same exact thing. So we are going to determine where the function values are positive and negative by testing values. That is, plugging them in. And that is exactly how this process got its name, the first derivative test. And here comes another exam tip. This one's very important. You will find that questions like this that deal with the first derivative test and the second derivative test, which we will be learning next module, College Board absolutely loves to make these questions free response questions for you guys. So Unfortunately, you are likely looking forward to seeing these questions as free response and not having the answer choices, which means you need to be very confident in not only arriving at the correct answer, but being able to thoroughly explain it and show all of your work. And as we've learned so far with free response items, it's important to have a strong, organized methodology or good, strong organizational approach to each type of free response problem. So with that in mind, let's jump into this one. In our example, we are going to find the critical points of f of x and identify the intervals on which the function is increasing and decreasing. So this problem has two different answers in it. We need to make sure that both parts are answered by the end of the question. So the first thing we're going to do is we're going to find the derivative. That is 3x squared minus 12. Now we need to set our derivative equal to 0. We add 12 to both sides, and we're left with 3x squared equals 12. Then we divide both sides by 3, and we get x squared equals 4, which means x equals plus or minus 2. All right. So based on what we know from previous weeks, we know that we can possibly have critical points at x equals negative 2 and x equals positive 2. From here, we're going to set up our intervals. From negative infinity to negative 2, from negative 2 to positive 2, and from positive 2 to infinity. So these are the possible intervals that we have. Now we need to go ahead and test values. That means we're going to select any x value of our choice within the given interval and plug it into the derivative. In this case, I chose negative 3 for my first interval because it's between negative infinity and negative 2. When I plug this into my derivative, I get 3 times 27, or 3 times 9, which is 27, minus 12, which is 15. This is a positive value. That means on this interval, my function is increasing. For the next interval, I'm going to choose 0. I love when I get to choose 0. It makes my function so much easier to calculate. And for this one, we got negative 12. Our function is decreasing on this interval. And for the last one, I'm going to go ahead and choose positive 3, simplify, and I get 15 again, which is positive. So let's take a minute and think about what this means. On my first interval, my first open interval, my function was increasing, which means it has a positive slope. On my second interval, it is decreasing, which means it has a negative slope. And on my third interval, it went back to increasing. While we don't have a full picture of the graph in front of us, we can sketch an idea of what that might look like. So here's a rough idea of what it might look like. And there are parts where my function is increasing, decreasing, and increasing again. The first time that changes is at x equals negative 2. And the second time that changes is at x equals positive 2. All right, so the last thing to determine is if these are minimums and maximums. And just from this quick little sketch, we can see that x equals negative 2 is a maximum value and x equals positive 2 is a minimum value. So we know that there's a local maximum located at x equals negative 2 because our function went from increasing to decreasing. They wanted the full point, so we also need the y value for each the local minimum and maximum value. In order to find that, we can go back to our original function f of x equals x cubed minus 12x minus 5 and plug these x values in. So we want to find f of negative 2 and f of 2. F of negative 2 will give us, let's see here, that will be 11. And then f of positive 2 that will give us 8 minus 24 minus 5, which is negative 21. So we have a local maximum at the point negative 2, comma 11, and a local minimum at the point positive 2, negative 21. Now please do not get confused. The points and the intervals look like they have the same exact notation. So you will want to make sure to make it clear that the negative 2, 11 and the 2, negative 21 are the critical points, the local minimums and maximums. And then you can write your intervals for increasing and decreasing. Now our function was increasing from negative infinity to negative 2 and from 2 to infinity, because those are where we got positive values for our derivative. And then it was decreasing from negative 2 to positive 2, because we got a negative value for our derivative. This next tip is not an exam tip, it's just something to keep in mind when working on these types of problems. Increasing and decreasing intervals are tricky, and there's a few tips that you want to remember for them. They always, always, always are open intervals, which means that you have to use parentheses, not brackets. The brackets mean the end values are included. The parentheses mean the end values are not included. And these intervals are always written in the interval notation, just like I used in this problem today. So please make sure that you are familiar and comfortable with using that interval notation. Well, that is all the material that I have for you this week. Please remember to keep up with all class activities, and remember to check in for the conference on Thursday evening. Have a wonderful, wonderful day.